Hello and welcome to another video for Calculus 1. So we are going to start integration now. So before we jump into integration, we are just going to discuss, I just want to make this short video about sigma notation because this is very important when we start integration and when we have to find the Riemann sum. So let's go ahead and discuss about sigma notation, which we use to find this sum. So sigma notation is a notation that's written here, so you can see it right here. So this is the sigma notation, which means so the variable k starts from m and goes to n, okay, and then it is written as a sub k. So this is the contracted form of that one, but when we expand that, it looks like this. So we are listing a sum, and then to summarize that sum or write that in shortcut, we use the sigma notation, and that is the sigma notation for that one. So a couple of things here. The so k, this letter k is called the index of the summation, m is called the lower limit, and then n is the upper limit of the sum. So let's look at some examples. So here we have the sum written in sigma notation. So we are just going to write this one in expanded form. So when you do that, so this is how we are going to write it down. So this equals, so we start to write, we start to plug in or substitute k from 1, and then we go all the way up to 4. So first we'll put k equals 1, that gives us the first term, and then we put k equals 2, that gives us to the that gives us the second term, and then we keep going with that one until we reach to k equals 4. Okay, so let's go ahead and list this one. So when we put k equals 1, we get 1 over, so 1 plus 2 is 3, so 1/3. And then we have to write plus because that's what this means, sum. It is a sum, so we are adding them. Okay, so now when we take k equals 2, we get 1 over 2 plus 2 is 4. Then plus when we take k equals 3, so it's 1 over 3 plus 2 is 5, plus 1 over, when we take k equals 4, is 4 plus 2, 6. And we have to stop here because that's the upper limit. So we cannot go beyond 4. So this is the sum in the expanded form. So this can be written in the short form using the sigma notation right here. Okay. So similarly, let's go ahead and expand this one. So just be careful here. We have two variables, x and k, but k is the one that is changing and x is a fixed variable here. Okay, so what we are going to do is we're going to replace k with starting at 3 and we go all the way to 7. So this becomes x to the third because we are starting at 3, then plus the next term is x to the fourth. So 3, 4, then x to the fifth, then x to the sixth, and then x to the seventh, and we stop there because that's the upper limit. So this is the expanded form, and this is the contracted form. Let's look at another example. So here we have an expanded form, and then we want to write this in the sigma notation. Okay, so here you just have to, so there is no any rule or any formulas that I can give you to write this one down. So what we have to do is we just look at the number pattern and we try to figure out what is that pattern and how can we represent that pattern in sigma notation. Okay, so if you look over here, so we have 1, 4, 9, 16, 25, and 36. So 1 is a square of 1. So this is 1 is squared. 4 is 2 is squared. 9 is 3 is squared. 16 is 4 is squared. And keeps going on. So this looks like the sum of this squared. So what we are going to do is, so this equals the sigma notation. And we start with k equals, so it's 1 because we start 1 is squared. And this is 1 is squared, 2 is squared, 3, 4, 5, 6 is squared. So we go all the way to 6, and then we write k squared. So that way, now when I plug in k equals 1, I get 1. When I plug in k equals 2, I get 4. K equals 3 gives 9, and k equals 4 gives 16, k equals 5 gives 25, and k equals 6 gives 36. So that's how we can rewrite that sum in sigma notation. Similarly, for this example, if you look over here, what we have is we have 1, so we can rewrite this one as 1 over square root of 1 because that's not going to make any difference. So we see that The numerator is always 1. The denominator is square root of 1, is square root of 2, is square root of 3, is square root of 4, and is square root of 5. So it is 1 over the square root of natural numbers. So we can write this as k equals, so we start at 1, we go all the way to 5, and then we can write 1 over square root of k. Okay. Now let's look at another example. Oh, so we have a theorem here. So these are very important when we do the Riemann sum. So you need to remember this sum, okay? So the first one is the sum of constant. That means if I write something like this, so for number one, if I write something like this, okay, k equals 1 to 5, and then if I write 2, that means I am adding 2 to itself 5 times. So this equals 2 because the k is not going to change. So 2 plus 2 plus 2 plus 2 plus 2, which is we are adding 5 2's. Okay. So instead of doing that, what we can say is this is 5 times 2. So that's what this means. Okay. N times C, or 5 times 2 gives us that sum. So now the second formula that we have, this is the sum of natural numbers. So for example, if I'm going from k equals 1 to 5, and then k here, this means 1 plus 2 plus 3 plus 4 plus 5. Okay, so we are just adding the natural numbers from 1 to 5. So for that, we can use this formula n times n plus 1 over 2, which means for this one, we can say n is 5. So 5 times 5 plus 1 over 2, which is 5 times 5 plus 1 is 6. So 5 times 6, 30 divided by 2 is 15. Now if we add these numbers, you should get 15 because 5 plus 4 is 9, plus 3 is 12, plus 2 is 14, plus 1 is 15. So we can use this one. So if you have like 1 to 5, then we can do by hand. But if you are doing 1 to, let's say, 500, then it's a lot of work to add all those numbers from 1 to 500 by hand. But when we use this formula, we can do that easily. Similarly, number 3 is the sum of the squares of the natural number. So, which means if we have k equals 1 to, let's say, 5 and k squared, it means 1 is squared plus 2 is squared plus 3 is squared plus 4 is squared plus 5 is squared. So you have to square them and then you have to add them. So instead of doing that, we can just use this formula, which means 5 times 5 plus 1 times 2 times 5 plus 1 over 6, and that gives us this sum. Similarly, this is the formula for the cube of natural numbers. So these are, I have four, there are more other some formulas, but these are the one that we are really going to use here. So this is very important that you need to remember this. Okay, so let's look at an example here. So we want to evaluate this sum. So a lot of time we might have to use a calculator for these things. Okay, sometimes we can do by hand. Like the first problem here, we can do by hand. The second one, we have to use the calculator. So for the first one, what I'm going to do is you can just replace k with, so 2 times 2 plus 2 plus 3 times 3 plus 2 plus 4 times 4 plus 2 plus 5 times 5 plus 2, which means, so this is 4 times 2, 8. This is 5 times 3, 15. The next one is 6 times 4, 24. And this is 7 times 5, 35. And when you add, you get 82. You can also use calculator for that, okay? And I have linked a video in the description where I showed you how to put this into the calculator and find this sum, okay? So you can check that. It's in the description. So go to that video and you can watch how to use TI-84 calculator to evaluate this one. For this one, if you want, you can go ahead and list them. So when you list it, so when you take k equals 1, so it's 9 over 1 factorial. When you take k equals 2, it is 18 over 2 factorial plus k equals 3, 27 over 3 factorial, and then keeps going on all the way to the final one, which is, so 9 times 17 over 17 factorial. So this is a lot of work to do by hand. So what I do is I will use the calculator, and again I have linked the video for this one in the description. Please go to that video and watch how to put this into the calculator. Okay, so using calculator, we get the sum equals 24.465. So again, visit that video, watch the video, and then you can use calculator for this one. That's all we do in this video. I'll see you again in the next video.